Okay, today we will talk about your assignment. So if you go to your Teams, you can see a lot of things. There are many things here I put up that you can use to help you to complete the assignment. Okay, so let's look at the question first. It's a long story, but basically you have a room 4 times 5. That is the floor size. So the height you have to assume you assume the height 5 meter. I don't know which is the more reasonable one you assume. It's supposed to accommodate 2 employees, and the room has a window size of 3 times 1, facing west. Now there's a contractor you have engaged to install an aircon. The contractor proposed a 2 horsepower, and then says that the aircon is able to cool down the room from 31 degrees Celsius to 26 in 20 minutes. And the electricity consumption is this much. And then your brother is not entirely convinced he needs a 2 horsepower lah. Because you have other option, right? Like 1.5, 1. Okay, so what you need to do is you need to analyze or investigate, more or less calculate lah, based on what you have learned in thermodynamics and heat transfer. Okay, so you're going to investigate the problem, and then with appropriate assumption, you got to make assumption along the way to calculate the appropriate horsepower given the criteria like 31 to 26 in 20 minutes and the power consumption. Basically, it's kind of open. You can investigate from which direction that you want. End of the day, you will need to be able to give a verdicts. Given verdicts, verdicts on whether you should use 2 horsepower or not. Okay. So you can settle with 1.5 horsepower, or you can go with 1. So there'll be a lot of calculation along the way. Anyway, so that one I will help you along the way. Now, of course, we don't want to know too much of things, except those things that you do that can earn you marks, right? Earn you knowledge is another thing lah. The most important thing is how you score the marks, right? So always like that. Okay, so you follow the format. You follow the format. So these are the chapters that you need to do. Introduction. Introduction is, I'll tell you later lah, what I want to see lah. And then energy analysis on the selected space. Power consumption of the aircon unit. And then discussion, conclusion, reference appendix. So these are the chapter that we must have. Now, introduction 20 marks. Energy analysis 25 marks. Power consumption 25 marks, discussion 20, conclusion 10. But the appendix you can read yourself. Okay, so this is basically, you have done assignment so many times, you know, like, these are pretty standard things that you mention what you should have in the analysis, discussion, conclusion, and stuff like that. So you can go through, but I will give you a more detailed guidance later. Yeah. Yes, 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 I have. Thank you for reminding. I have done the recording secretly without your knowledge. Okay, let's move on one by one. So when you see the red dot, I assume recording is running now. Introduction, 20 marks. Okay, so you just give an explanation on vapor compression cycle. Okay, vapor compression cycle. That is being used widely in the air conditioning units. Okay, so explanation on VCC, vapor compression cycle. And also factors that influence the efficiency of aircon unit that uses VCC. Okay, so no need to talk about other things. You just talk about these two things. Further. Of course, you want to talk about other things, pretty much up to you lah. But when I award marks, I will just search for what I want to give marks. It's always like that. You can give like whole ton of information. I just read what I want to read. Okay, there's the problem with students. Sometimes I think most of the time you don't give the lecturer what the lecturer wants, and then you think that you have done a tremendous, wonderful job, by giving a lot of information. But that's not what the lecturer wants. Okay, so make sure you give what the lecturer wants, and I already mentioned to you, as simple as that. Okay, now then energy analysis. So you have a selector space And then we have a window facing the west. Let's assume this is the west, okay. So then normally office building, we will assume there's a door. There's a door here, or maybe there's a door here. I'm not sure lah. There must be a door lah. Okay, so you assume there's a door. Okay, so your office building, beside your office building, do you have any room that connected to the building? To your office block lah, your office. So that one you got to assume lah. So maybe your building is inside a office block or something like that. Just like this room lah, we got connected to the other two rooms. Right. So you might be just a room itself. Bungalow, not sure. So you need to go and assume. Make proper assumption. Now, why we need to do that? Because you are supposed to remove heat from this space. You need to remove heat from this space. This one you need to remove the heat. You need to extract out. So you're going to extract it out by using an aircon unit. Now, by saying that we need to remove the heat, it means there must be some heat source inside, right? There will be heat source. So the heat source will be coming from the two employee. And then if you have TV, you have computer, you have fridge, you have lighting, everything. All these will actually will produce heat. Those are the heat that you need to remove also lah. So that one you need to go and search literature. So what is the heat transfer or the power output of all the electrical appliance that you can think of? You don't need to think of anything, because this is the office building, so be logical. So the electrical appliance or equipment that you can have most likely will be like photocopy machine, laptop, fridge, might not, might not lah. So it depends on you lah. Okay, of course, you put those commonly found in office, lah. Not sure. You want to put like karaoke set, TV set, massage chair. I'm not sure. You want to put, you can put that. Okay, so just assume few electronic equipment, and then you need to go search literature. Now, along the way, these are the heat from the people or the equipment inside, and then there also be heat coming in from the sun, from the sun, and then the outdoor, maybe the room beside, just next to your office also will have heat comes in, right? If the temperature of the room beside your room is actually higher, and then your room is actually lower temperature, definitely heat will transfer through the wall. Now you can make assumption, up to you lah. You can make assumption this is a very thick wall, then the heat transfer can be ignored. Also can, up to you. If you say just a partition, then you need to search how much is the heat transfer. Of course, this will be we will learn in heat transfer, which is the second part of our study. We haven't learned yet. So you can put on hold on this energy analysis for a bit. Okay, so you can put on hold first. But if you don't mind, you can actually make assumption. You like say that the heat transfer is not significant, okay, then you can actually ignore it lah. Or you can say that just assume some amount, just assume some temperature. Let's say the next the room next to your office, you say that those two rooms are occupied, and then the temperature of the rooms is the same with the temperature set in your room. Now, in this case, if you don't have temperature different, then you don't have heat transfer, lah. Okay, so you don't need to worry about the heat transfer. Okay, so same thing lah. So depends on the assumption lah. This one you need to make appropriate assumption to take care of the heat transfer from outside. Of course, the window here is something that you must do lah, because the window here on the west side, so you will be facing the sun for half of the day, not really half of the day, half of the morning, not morning. What do you call that? Afternoon, yeah, afternoon, yes. Okay, so then you need to assume how much heat from the sun actually that goes into the room, and then you need to remove. Whatever heat goes into the room, you need to remove with your aircon unit. So basically, this is what does it mean by energy analysis? You have to analyze what are the heat that goes in, okay, so that you know how much you need to remove. Okay. So this one, I'll leave it to you. As I say, you can just make some simple assumption, and then you don't need to do the calculation. Okay. But then the heat from the sun going through the window, going into the room, then you need to take into consideration. People inside, equipment inside also you have to take into consideration. Okay, so even the heat from the upper floor or from the lower floor, you can also make some assumption, proper assumption. Then you will not need to take those also. Now, if you don't mention, your energy analysis is not complete. Okay, so make sure you mention somewhere. If you don't want to consider the heat transfer from any way, any direction or any medium, you just have to mention. And then with proper assumption, you don't need to do. No need to do means no need to calculate lah. Okay, so now the heat that goes through the sun, the heat from the sun goes through the window. I already attached a journal for you to read. You can find here in the assignment channel. You can find. You can just make use of this journal. You even no need to go through the whole journal. This is a heat transfer analysis of windows with Venetian blinds, a comparative study. So you have blind to cover the window. Okay, so some researcher has done the measurement, a lot of measurement. So if you want, you can actually go through, see how they actually analyze compared with theoretical model and the experimental result. Now there are a lot of result. You can make use of the result here. Okay, like this one. This is the flux, this is the heat goes through the window with the Venetian blind at the time, okay, at what time of the day. The 12 is the maximum lah. Okay, so then you can actually get the reading from here. Okay, then you can actually put into your calculation. Okay, so this one, there are a lot of information here you can use. You just pick the one that suitable for use. Definitely this one is going to be useful. Okay, so I'll leave it to you. If you don't mind, you can search again. Not search again. You can search because you haven't done any searching yet. You can go do your own literature review. Get a literature that you think it's going to help you more than this one. Okay, then you can go ahead, no problem. Alright, but from my side, I try to help you also lah. Okay, so I already provided you with this one. If you are satisfied, go ahead. If you're not satisfied, you can do your research. Okay, no problem. So the energy analysis is like that. It's pretty simple, straightforward. So if you want to consider the heat from next door, so you have to consider the heat through conduction. Okay, conduction. Now, of course, I'm telling you the minimum, the minimal requirement that you need to achieve lah. Of course, you want to score A plus A, then there are other things you need to consider. That one I will not mention lah. It's up to you lah. You get me? Because cannot be everybody getting the same marks for assignment, right? Morning. Okay, so that's why I'm just telling you enough. No? Don't base on exactly 100% what I'm telling you. If you want to get more, better mark, you need to do more. So you have a mindset like that. You don't have some expectation you have done according to what I say, you're expecting A plus. No such thing. Got it? So I'm just helping you to achieve the requirement. Maybe you get some about 60 marks like that lah. You want to go more than that, you need to do your own research for a bit, put in something extra. Extra means has to be logical also lah. Okay, so I'm just telling you the minimum. The rest, if you want to get more, you have to do it yourself, your own study, your own research. Okay, so those are the 25 marks energy analysis. So the point is you need to consider all the possible source of heat and then take care of them one by one. If you don't want to put into your calculation, you just need to make some good assumption, good logical assumption, then you don't need to put in your calculation. Whatever is it, you have to take care of them one by one. Okay. Okay, good. Power consumption. Okay, excuse me. Now the introduction VCC, vapor compression cycle, also I have provided you the information. Okay, so where is it? Okay, I already shared with you the link, so you can get from the channel. Of course, there are other sources you can get this type of information. Because VCC is a very common cycle, so you can get a lot of information. This is the design of a vapor compression refrigeration cycle. So it's a vapor compression cycle in short. So you can actually go through this and then you should be able to write your introduction pretty well. Okay, so if you think this information is not enough, I also attach two reports from previous students. You can go through that. Now this basically for the VCC, so you can refer the VCC, the cycle, vapor compression cycle. Okay, so that one you just have to go through this. Okay, so now that's our introduction. Now, to do the power consumption, you need to have good understanding of VCC Okay. Now the website that I shared with you, This one is also give you good information on how you should calculate the power consumption based on some assumption. You read through, you can actually get some idea on what are the assumption you should make. Okay, but the calculation part, you can actually check the two sample, the student sample. You check that one, then you should be able to do calculation on VCC. Okay, so that one I leave it to you. Power consumption. So the assumption that you should make, you can get some idea from the website. How to do the power consumption calculation, you can refer to the two example I have attached. Okay, so you do your part. You do your part. Of course, you can go through those materials. Anything you can come back to me. It's very easy. You just come back to me, ask the question. I answer. I answer every question. Answer only lah. Whether you are satisfied with the answer is another thing lah. Okay, and then conclusion. This one's pretty much straightforward. Okay, so discussion always based on two aspects. So first is the validity and then the limitation. Okay, the work that you have done, whatever you have done. So what is the limitation of your work? And how valid your work is. Okay, so you normally you just discuss from there. From those two perspective, where to. Okay, so conclusion. So then you need to give conclusion. Based on your analysis. So what horsepower aircon that should be used, okay? And whether your calculation, your effort put in, able to help you to answer the question of the assignment. Okay, basically just conclude lah. So nothing much from there lah. Now this one we don't have presentation. So that is not so good thing. You know, right? Because presentation is the place normally the lecturer can help you a lot lah. Especially the Q&A. Okay, because normally that's the part lah. We can help for a bit lah. Since there's no presentation, no Q&A, so you got to make sure you put more effort in your writing. Okay, any question? You need time to go through. So I believe you should do it as soon as possible. That's why even though we haven't covered the heat transfer, I also feel that you should get this assignment and start working on it. Okay, but as I say lah, so if you want, you can just analyze the heat transfer to the window. The rest you can just make assumption and get rid of them. Okay. But of course, along the way, when we cover the chapter of heat transfer, you think you still want to do analysis on the heat source? Yes, no problem. Okay, so you have like half a semester to do that. Along the way, you think you want to add for the heat transfer thing, it's up to you lah. Okay, but for now, I think you can start on. You can start on the VCC lah. Calculate, learn how to calculate the power consumption of VCC. When you calculate the power consumption along the way, you'll be able to tell the heat transfer rate and things like that. Then you should be able to calculate other things. Okay, now the other thing is heat source is like the one that you have live heat source, like the person, the equipment. Now you need to cool down air. You need to cool down air. So in air, you have humidity. Humidity means H2O. So in air, you have H2O. It's not only air. So when you cool down air, you are actually cooling down two things. You're cooling down the air and you are cooling down the water vapor. Okay. Now, if you notice, if you're not sure whether you notice or not, the outdoor unit, normally you have water dripping down, right? So that water is from where? That water is actually from the room, water vapor. So because of the dew point, because the water vapor reached the dew point, then it condenses into water, and then the water is being removed from the room. That's why aircon room is a bit dry, as the way people knows it, right? Aircon room normally is a bit dry because the air, the humid, the humidity is tends to become lower after air conditioning, because the water vapor is being removed from the room. So literally, you are cooling down the air and also you are cooling down the water vapor. If it's reached the dew point, the water from the room will get removed. So normally you air Malaysia in Malaysia is like what 7% relative humidity. I think about that lah. You can check with the chair. So when you cool it down, let's say you cool it down to 26 or you select a target like 26 or 25 degrees Celsius. Yeah, when you cool it down along the way, the humidity also become less. Maybe it will become 55 relative humidity or 60. So to calculate how much heat you need to achieve that, you are going to use the psychometric chart that day I mentioned for a little bit, psychometric chart. You can use the chart or you can just use the calculator here. This is you just click the link. It'll bring you to the what do you call that? The calculator. So here you can enter the temperature and then the relative humidity. From there, let's say our temperature 30, relative humidity 70, and you can calculate. So what we want to get here is actually the enthalpy. So this is the value that we want. This is the enthalpy, means it's the enthalpy of air when the humidity is 70% and the dry bulb temperature is the normal temperature, and there's a wet bulb temperature is evaporating temperature. When the water evaporates, what temperature, that is the thermometer register. That's how they measure the humidity. So you got to read a little bit if you don't have any idea on what is wet bulb. So there's a way. I'm not sure whether you learn this in your secondary school or not. Normally you have two thermometer. You cover one thermometer with wet cotton, wet cotton, and then you string the two things together. and then you read the temperature. Okay, I'm not sure if you've done that. Okay, but that is web out temperature. So you can just ignore, no problem. You can just input your current temperature and then you input your relative humidity, and then you calculate, you can get your enthalpy. Now let's say you want to reduce it to 25 degrees Celsius with the humidity of 60, let's say. Now it becomes 55. So just now was like 72. So basically you get about 17 kilojoule per kg. So that is the difference is the heat that you need to remove per kg of air. You get it? So this is actually a calculator to calculate the enthalpy, enthalpy change. Now basically you need to lower the enthalpy of the room. Okay, you need to lower the enthalpy of the room. Okay, so the heat transfer is a change of enthalpy. Okay, so let's say you assume 70% relative humidity at 30 degrees Celsius, you cool it down to 60% relative humidity at 25 degrees Celsius. The heat content that you need to remove is the change of enthalpy. Okay, so very simple. That is the change of enthalpy. Now, of course, if you don't use the calculator, you can use the psychometric chart I showed you previously. The psychometric chart. Uh, it's difficult to use a psychometric chart because so many lines. That's why I give you the link, so you can use the link. No problem. This is a. Oh, this is for refrigerant. Yeah, you need to choose a refrigerant. When you study the VCC, you know lah. Okay, you need to choose the refrigerant. Normally it's R22 lah. You want to go R134A also can. Hmm. Ah, this is a psychometric chart. Okay, so not sure it's clear or not. This is relative humidity 70%. Your dry bulb temperature, let's say 30, you go up to yeah, you have to really pay attention. Okay, 70% humidity. 70% humidity, so somewhere here. So you go all the way out. And then you get your enthalpy here. So about 70 something, 70 something. 70%, 30, 70%. 70%. Somewhere here. So the enthalpy kilojoule per kilogram dry air. So we come to here. 70 something lah. 70 something. I think pretty near to 80. Saturation temperature. This is the dew point temperature lah. I get a lot of information from this psychometric chart. Volume, cubic meter, this is specific volume. Relative humidity. Okay, so if you don't want to use this, you just go to the website I share with you, which is easier lah. Okay, which is always easier. 30%. To humidity 70%. Yeah, 78.22 lah. Okay, so you can get from the psychometric chart, or you can use this psychometric calculator. Okay, so you just mention that in your report, just go to the website. Okay, so for your convenience, I I accept lah. I accept this one. You don't need to go to the psychometric chart, to get it. It's a bit difficult lah. Okay, so you just go to the website I share with you. Okay, so I think I'll just talk about your assignment until here lah. The rest of the thing you have to go in and jump into it, and then you discover something, then you know what you don't know. Then from there, try to fix everything lah. Okay. Anything you think you need, you just ask me. I'll try to provide you. I already provided you a lot of things that I think you need lah. The psychometric calculator, the two example for the VCC calculation, power consumption calculation. And this will be the question. And then this is the heat radiation, heat transfer from the sun. And this is the design for the vapor conversion cycle. You can use this for your introduction. Of course, you can get information from other place will be better lah, or else you're going to have problem with the Turnitin score. You get me? Because one of you submitted, the first one submitted definitely score will low. The second one submit because of the first one submitted, the score will be high. You get me? So that is sometimes that's why I don't like to provide information, because it will cause the Turnitin score to be high. But anyway, so I just let you know lah. So if you think why you have the question why the score so high, most likely somebody have already submitted using the same reference. Okay, that's why score is high. Okay, but you can take this as a reference lah. Okay, so don't base solely on it lah, just to avoid the problem the turning problem. Okay, so let's get attendance and then move to our next classroom. Okay, this 3%. No limit. I will read what I want to read as usual. If the things that I don't want, I will just skip. Very simple. Oh, not like this. Four, 4, 3, 3. Okay, so I think I can go turn. Okay.